Okay, students, so the last example that I want to discuss from this few previous slides is shown over here. In this problem, what we want is to find the angle which the vector A makes with the y-axis. What is given to us is a vector A of unknown magnitude, and that vector A makes an angle 30 degree with the z-axis, and if we project the vector A onto the xy plane, the resulting projected vector makes an angle 40 degree with the x-axis. And we want to find out, as discussed, the angle between vector A and y-axis. So in order to solve this problem, we will use the concept of direction cosines. Now first, from our concepts of direction cosine, it is evident that the component of z along of vector A is nothing but A cos 30 degree. Now if the magnitude of vector A is r, then it would nothing but be r cos 30 degree. In a similar way, I can take the projection of vector A onto the xy plane. Now this vector A makes an angle of 60 degree with the xy plane. So the projection of vector A onto the xy plane will have a magnitude of r cos 60 degree, which is nothing but r sin 30 degree, and therefore its magnitude is r by 2. Now after you have projected, you are going to end up with a vector. Let's call that vector axy and forget the magnitude for the moment. Now think of an independent vector axy present in the xy plane. What is given to us is that this vector axy makes an angle 40 degree with the x-axis. Therefore, we can find out the component of vector axy along the x-axis by taking the dot product with the angle. So the magnitude of vector axy along the x-axis is nothing but axy cos 40 degree. Similarly, the magnitude of vector axy along the y-axis is nothing but axy sin 40 degree. So now that we have found out the different vectors magnitudes, let us go back to the figure. We have a vector axy, we have a vector, the magnitude of vector along ax is also known to us, the magnitude of vector along the y-axis is also known to us. Now these magnitudes are nothing but obtained from the actual vector A. So now if we equate the magnitude of the component along the y-axis with the direction cosine concept, we can find out what is the actual angle that this vector makes with the y-axis. So now that we have obtained ay, the magnitude along the y-axis, all we need to do is we have to find out that value of m, or direction cosine, that value of m for which this relationship holds true. So as we can see, we will end up with theta equal to 71.25 degrees. Thank you, students.